Hi folks, here is the second video for the Unit 1 Day 4 work on multiplying vectors by scalars. So we're going to look at an example here of two unit vectors and finding the magnitude of 4 times u hat minus 3 times v hat. Remember that we always have to draw a good labeled vector diagram in order to solve any vector addition problems. So let's start with our two unit vectors. We can identify them as unit vectors because they've got that little hat notation on top and they have an angle of 30 degrees between them. Now we know that when we are labeling the angle between two vectors, it has to be when they're tail to tail. So here I've drawn my first piece of this diagram, two unit vectors with an angle of 30 degrees between them. On the diagram that's probably bigger than 30, but that's okay. So now we want to do a diagram that shows 4 times u hat minus 3 times v hat. So if I was going to do 4 times vector u, that would be bigger. I'm going to try and draw that about 4 times as long. Sure. So that's 4u hat. And then negative 3v hat. That's going to go back in the opposite direction as v. Like that. And I can just draw in my original v hat there because I will need to associate that 30 degrees into my new diagram. So I'm going to take another color and draw in the resultant vector. Not unit vector anymore. So I'm just going to use an R for resultant, just it's a little bit shorter and easier to write than the 4u hat minus 3v hat. Now I know that v hat and negative 3v hat are parallel to each other, so I can use a Z pattern to put a 30 degree angle up there. And then I may wish to redraw this diagram instead of as a full vector diagram. That looks like a 90, but I definitely don't know that it is, with just the magnitudes in there, and I'm going to say that that's the magnitude of r. So if I want to find the magnitude of this resultant vector, I'm going to be using the cosine law with the 3 and the 4 as the two sides and the 30 degrees as the angle between them. So the magnitude of r squared is 3 squared plus 4 squared minus 2 times 3 times 4 times cos 30. And remember that I don't need to see all of your work with this. I do need to see one line where you show me what equation you're using and you put your values in. Sorry, my 30 got a little messy there. But then past that, I will really just be assuming that you can calculate this out. And I get that that is about 2.05. So I've done my vector diagram, I've labeled the angles, I've translated the vectors to be tail to tail to add them, and then this is a kind of optional step, this drawing it just as a nice regular triangle, but I think it, especially if your vector diagram has gotten a bit messy, it might be easier for people to see that. And then I'm just going to kind of summarize, 4u hat minus 3v hat equals 2.05. So the magnitude is 2.05. Now this is a continuation of the same question, and we want to figure out what the angle or the direction of this resultant vector is. So I'm going to redraw that same diagram I had here. Draw it kind of the same. So I had 30 there, that was a 3, that was a 4, and this is 2.05. So not super accurate, but we're going to kind of go with this, that I've got this magnitude here. Now I want to find the direction of this resultant vector. So this is my resultant here. And I can label a direction angle in there. And then this angle will describe where the resultant is compared to my original vector u, because this was the 4 u. So we could have this as 4u hat and 3v hat and kind of change that back into a vector diagram. And we're looking for that angle. So we know that I've got 30 and 2.05, and I'm going to look at the magnitude of that 3v hat as the 3. So we're going to take this and look for sine theta using the sine law. So sine theta over 3 equals sine 30 over 2.05. Now we are going to have to solve for theta. One thing we should always check on is, can this angle be an obtuse? And we know that it can't. We always kind of want to check for that ambiguous case. When we have all 3 sides, I know that the largest angle is going to be across from the 4. So this, because I know this base here, I know the biggest angle up here is going to, that will be across from the one that's a magnitude of 4. So definitely this theta could not be an obtuse angle, even though otherwise, without that information, we could kind of wonder, this is a potential for the ambiguous case, but because we know that that's 4, this has to be the biggest angle in the triangle, so that that one cannot be greater than 90. So we won't have to consider that. So again, I'm not going to require that you guys show me a ton of work. So sine of 30 times 3 and then divided by 2.05, and I get theta is about 47.03 degrees. Now the important thing here is to be able to explain what this theta actually means. So the theta is the angle between, remember we're always talking tail to tail. My original u hat and v hat were like that, and then my resultant was over here. And this angle, this 47 degrees, is this angle in here. So that's 47.03 degrees. So my summary here, 4u hat minus 3v hat is 47.03 degrees. It's going away, it's from u. We're measuring that angle from u hat. And that's measuring away from v hat. It's not going back towards v, it's going in the opposite direction. So I'll put away from v hat. Okay? So that's a description of what the angle is for the resultant compared to my original vectors u and v. Now because the vectors don't actually have a specific location, we could have drawn this a million different ways. Those u and v could have pointed in any direction, but we know that the resultant will be 47 degrees from the u moving away from vector v, wherever the u and v are oriented. Similar kind of question here. We're going to calculate the magnitude and direction of 8u hat plus 5v hat. So I'm going to, again, kind of draw little, these are still the same ones with the angle of 30 between them, but now we've got addition. So I'm going to draw 8u hat, and this is not going to be to scale because I'll run out of space, and then plus 5v hat, and then my resultant vector will go from there. So I know that this original angle in here is 30. That would be a 30 there. And then we're going to form a C pattern that will give me an angle of 150 up top. So we're going to use the cosine law. The magnitude of the resultant squared is 8 squared plus 5 squared minus 2 times 8 times 5 times cos of 150. So pop that all into my calculator. And do the square root. We get about 12.58. I may have to reprint this one. So about 12.58 is the magnitude of the resultant. We're going to continue and kind of do both of this together to calculate the direction. So I'm going to label a new theta perhaps in there. And again, when we're considering this, we're not going to have an ambiguous case. We already have one angle bigger. So just kind of drawing this sort of roughly out. The stuff we know, 12.58, that's a 5, that's an 8, that's 150, and my theta for the direction angle down at the bottom, because that's the place that you and the resultant will be tail to tail. You always want to have your vector angles between them tail to tail. So if I'm solving this for theta, sine theta over 5 using the sine law is sine of 150 over 12.58. So I get a pretty tiny angle here, which makes sense, but it's about 11.46 because we have such a big angle there. This is going to be the smallest one. So 11.46 degrees. And we have to specify where that 11.46 degrees is. So 8u hat plus 5v hat is 12.58. And this is going to be measured 11.46 degrees from u hat. So this is measured from the original direction of u hat towards v hat now, because v was going this way. So the resultant is measured from u moving towards v. And just another reminder with this question that I have broken this down saying find the magnitude, find the angle. But if I just asked you for the vector, you have to recognize that on your own that I am asking for both magnitude and direction. So if you're ever asked just for a vector as an answer, make sure you're answering both kind of A and B parts of that. And I think I've got one more. So here we want to find a unit vector. So we have magnitude of u is 4. I'll draw a u there. And magnitude of v is 5, and the angle between them is 120. So I'm going to draw this bigger than 90. That's 120 degrees between my two vectors. So I want to find a unit vector in the same direction as u plus v. So really what the unit vector is, remember that would be 1 over the magnitude of u plus v times vector u plus v. So really we want to find the magnitude and then multiply that by that resultant vector. So I'm going to add my vectors, head to tail, draw in my resultant for u plus v there. And remembering that I'm going to have a C pattern, translate that angle. Wow, this is really not to scale, but that's okay. Up there. So we know that the magnitude of u is 4 and the magnitude of v is 5. So again, you can redraw. I'm going to kind of save some time on this one and just recognize that the magnitude here is going to be, using the cosine law, 4 squared plus 5 squared minus 2 times 4 times 5 times cos 30, because I use the C pattern up there. Okay, so I get about 2.52, which looks kind of small, but I have really not drawn my 30 degrees accurately at all up there. So it's probably pretty realistic. So this unit vector, I have to take 1 over 2.52 times vector u plus v. So I don't actually know the direction, or I don't really have a measurement of u plus v, but I know that I have to have the unit vector as 1 over 2.52. So whenever you're asked for a unit vector, you're going to find the magnitude of the vector you're talking about and multiply that vector by 1 over the magnitude to shrink it back down to be the size of a unit vector with a magnitude of 1.